welcome back. In this video I want to talk about another challenge example or challenge problem for the composition of trig functions with their inverses. Guys, this is going to be the last problem for this section, and then we will start talking about the solving trig equation. So here we can see that there's a sign outside, and then inside there's not only one inverse function, there's a combination of two inverse functions. There's the sine inverse and the cosine inverse. So guys, first thing first, we cannot just distribute that sign. That is something we cannot do because it's a function, okay? So we have to kind of go back and recall one of the basic laws or one of the basic properties for sines, which is called the sign of the sum. So before trying to distribute this, guys, please make sure that this is not a sign, is not multiplied to it. It's a function by itself. So one has to think of this as a sign of the sum. Let us quickly remind ourselves what is the formula for the sign of the sum. Guys, if we have sine of a plus b, which is also thought of as the sign of the sum, it is equal to sine a cosine b plus cosine a sine b. Guys, these are all connected, interconnected concepts. So one has to kind of always remember, or one has to have the formula sheet in front of you, in front of us to actually do any of these things involving trig functions. Okay, so once we have that, first of all, what we are going to do is we are going to kind of think of this as my a and this as my b, and using the sign of the sum, this can be written out as sine of the sine of a first. Sine of a is sine of sine inverse of 1/2, right? And then I have to multiply that by the cosine of b, which is cosine of the cosine of b, and b is my cosine inverse, 5/13. That closes that. So, and I need to write it in one straight line. So then, guys, there's a plus. Then I have, what do I have next? I have the cosine of a. So cosine of a is sine inverse, so it's sine inverse 1/2. And then, guys, times I have the next one is my sine of b, and b is cosine inverse of 5/13, cosine inverse of 5/13, and close all that. Okay, that is going to be my first step using the sign of the sum formula. Now moving on, simplifying things, guys, this is sine and sine inverse. That is the first condition. That's a good thing because they can kind of cancel each other out, but it has to meet the condition that this 1/2 has to be in the domain of the sine inverse, and 1/2 is 0.5, which lies between -1 and 1. So if both the conditions are met, and they are met in this case, that means they kind of cross out or they cancel each other out. I think that's the right word to use here. Rather than saying crossing out, they kind of cancel each other out, and I am left with only 1/2. Guys, same thing here. There's a cosine and it's inverse. And 5/13 obviously lies between -1 and 1. It still lies in the domain of the cosine inverse. So this will cancel each other out, and I'll be all still left with 5/13. So that was not too bad. We were able to simplify this. But here we have some problems, like, because this is cosine, this is sine inverse, they are not inverse of each other. Same thing right here as well. But we know how to handle these types of composition functions. Guys, the good thing about this function still is that sine inverse of 1/2 is something that we can quickly figure out from the unit circle, because 1/2 is a value for sine that lies on the unit circle. So let me grab my unit circle. Look at my unit circle. Obviously 1/2 is positive quantity. It has, so that means it is going to be in the first quadrant. So in the first quadrant, I get sine of 30 degrees is giving me 1/2. So this is cosine of sine inverse 1/2 is 30 degrees, right? Because sine inverse 1/2 is 30 degrees. Guys, I'm skipping that step because we have already seen a lot of examples doing that. So that's why I'm just using my unit circle and just writing the value for that from the unit circle. Guys, then I have sine inverse of this ratio. 5/13 obviously is not on the unit circle, but we know how to handle these guys. To handle these guys, I'm going to take it up right here. What we have to do is we have to set this cosine inverse of 5/13 equal to any variable. I'm going to say theta. So if it is equal to theta, that means we are just simplifying sine of theta, right? Because we are setting this equal to theta, so I substitute this back. So I just need to find the sine of theta. At the same time, we will not be able to figure this out from a unit circle. 5/13 ratio is not on the unit circle. So what we like to do is we like to analyze this inverse equation in a more user-friendly way, and we know the fact that this equation is similar, or it's exactly same as saying cosine of what angle theta, for what angle theta is the cosine of theta? 5/13. So guys, these two equations are basically equivalent equations, but this is a more user-friendly equation, so we like to work with this one. Now for this equation, again, we know that it's a 5/13 is a positive number, so it's going to be in the first quadrant. So if it is in the first quadrant, let us start drawing the reference triangle. This is my theta. Obviously this is 90 degrees. And then cosine, the definition for the cosine of theta is it is adjacent over hypotenuse. That means this is 13. This is 5 adjacent over hypotenuse. Guys, all we have to do is we have to find the opposite, and we know it's like, if you already know, then you can easily write that the length for the opposite is 12, because it's a 5, 12, 13 triangle, or you can use a Pythagorean theorem to find the missing side. We have all the three sides. This is the opposite, this is the hypotenuse, this is the adjacent. What we need here is the sine of theta. Just look at this reference triangle. What is the sine of theta? Sine is the opposite over hypotenuse. That means it's going to be 12/13. So let us try to do it in the next step. But here I'm going to simplify this. This is 5/26. Cosine of 30, again, I'm going to look at my unit circle. Cosine of 30 is radical 3/2. Then sine of theta is 12/13. So I'm going to replace that by 12/13. Simplifying further a little bit, it's 5 plus 12 radical 3/13 times 2 is 26. So I can just write that 26 once, and this is my final answer for this. Okay, so guys, there's few key things. One is, please don't try to distribute this sign, because it's a function. You're not multiplying it, so you have to go back and you have to recall that it's the sign of the sum. So first we use that. We use the formula for the sign of the sum. We wrote it out. Then first to these terms, the half of it was like easy, because they would just cancel each other out. So we got these two ratios. But here on this side, this was not too bad. We could just see it on the unit circle. For this, we had to do some substituting and then drawing the reference triangle, but we could bring it all together, and finally this is my final answer. Guys, that's it for the composition of trig functions with their inverses. If you have any other questions on this section, feel free to reach out to me through my YouTube channel. But till then, that's it for this section. I will see you in the next video with solving trig equations. Till then, take care.